IBM will announce an advance in an entirely new kind of computing. That's the difference in quantum computing, a technology being developed at IBM, Google, and others.
What if everything you've ever known about the universe is wrong? Albert Einstein's theories have been our guiding star for over a century, but quantum computers just pulled the rug from under his most cherished beliefs. A breakthrough experiment has not only challenged Einstein's deterministic world, but has thrown us into the deepest mysteries of reality, shaking our understanding of time, space, and the very fabric of the cosmos. Stick around, because what comes next is going to flip your world upside down. The shockwave of quantum computers. For over a century, Albert Einstein's theories of relativity stood as the undisputed foundation of modern physics. His groundbreaking ideas about the nature of space-time, gravity, and light bending around massive objects shaped the way we see the universe. His equations were seen as the ultimate explanation of reality, until now. Enter the quantum computer, a machine that doesn't just follow the rules of classical physics, but redefines them. Quantum computing is challenging everything we thought we knew, exposing a universe far stranger and more chaotic than Einstein could have ever imagined. Imagine the shockwave in the scientific community when quantum computers revealed that space-time isn't this smooth, predictable fabric that Einstein described. Instead, these advanced machines are uncovering a universe where unpredictability, uncertainty, and randomness rule the day. What quantum computers have proven is that the very core of reality is something far more complex and out of our control than Einstein's deterministic view ever allowed. For decades, we've believed that the universe functions like a finely tuned machine until quantum computing cracked open the door to a chaotic quantum realm where anything can happen. The universe is no longer just an orderly system. It's a playground of infinite possibilities. As quantum computers simulate the very fabric of space-time, they expose new facets of reality that Einstein's theories failed to account for. These machines are giving scientists a look at the quantum world, where the rules aren't predictable and where randomness governs events. The implications are staggering. Every computation reveals more about a universe that is as chaotic as it is mysterious, upending everything we've known for over a century. The very nature of reality itself is on the line, and quantum computers are forcing us to confront the uncomfortable truth. The universe is not as orderly as Einstein thought. The question isn't just whether Einstein was wrong, it's whether everything we thought we knew about the universe is ready to crumble. What's coming next will challenge your very perception of reality. Stay tuned, because the shockwaves are just beginning. Quantum entanglement. Einstein's greatest frustration with quantum mechanics lay in the strange phenomenon of quantum entanglement. He famously referred to it as spooky action at a distance, unable to accept the idea that particles, no matter how far apart, could instantly affect each other's state. For Einstein, the universe was a predictable machine, where information couldn't travel faster than light, and where actions followed a clear, logical order. But quantum mechanics completely flipped this on its head, and Einstein couldn't make peace with it. However, quantum computers, using the very principles that Einstein doubted, have proven entanglement to be not only real, but also fundamental to how reality operates at the quantum level. Quantum particles, entangled over vast distances, defy classical logic and act as if they are instantaneously connected, breaking the speed limit of the universe itself. These machines have demonstrated that entangled particles are not just spooky, but are crucial in understanding the true nature of reality. Quantum computers are revealing an interconnectedness between particles that Einstein couldn't even fathom, showing us that everything is connected in ways that we are just beginning to understand. In the latest quantum experiments, entanglement has not only been confirmed, it's shaping reality. As quantum computers simulate these particles interacting, scientists have discovered that their entanglement isn't just a peculiar phenomenon. It's the key to how the universe works at the most fundamental level. The particles don't just communicate, they bend space-time itself, altering the very structure of the universe. What was once a theoretical anomaly is now a proven reality, and it's revealing a universe far more bizarre than Einstein ever anticipated. If entanglement can influence space-time itself, what else is quantum mechanics hiding? The deeper we dig, the more we uncover. But this is just the beginning. Hold on, because what's coming next will blow your mind. The quantum simulation of space-time. Einstein's vision of space-time as a smooth, predictable backdrop to the events of the universe is being obliterated. Quantum computers are now simulating space-time itself, and what they're uncovering is beyond anything Einstein could have imagined. In a recent experiment, scientists used a quantum computer to model space-time as if it were a living, breathing entity, and the results were astonishing. Far from being a static stage for cosmic events, space-time is an active participant in the unfolding drama of the universe, shaped by the interactions of quantum particles. What's even more jaw-dropping is the way quantum particles appear to influence space-time during these simulations. As these particles entangle and interact, they don't just affect each other, they create ripples in the very fabric of space-time itself. The idea that space-time is an emergent property of quantum processes, rather than a fixed, immutable backdrop, challenges everything we've believed about the universe for over a century. Einstein's theories of relativity, while brilliant, may only be the tip of the iceberg when it comes to understanding the true nature of space and time. This is no longer theoretical. It's happening right before our eyes, and it's transforming how we view the very universe we live in. As quantum computers continue to simulate the complexities of space-time, we are beginning to realize that our understanding of gravity, time, and space is far too limited. The implications of this discovery are mind-blowing. What if space-time isn't the fabric of the universe, but rather a dynamic, shifting entity that is influenced by quantum particles and their interactions? If quantum mechanics shapes the very fabric of space, could it be that time itself is not a fixed, linear sequence of events but a fluid, quantum-driven process? These are the questions quantum computers are now forcing us to confront, and the answers may be more disturbing than we're prepared to face. As quantum simulations continue to push the boundaries of space-time, what will we uncover next? Are we ready to accept that the universe is far stranger than we ever imagined? Stay with us, because the journey is just getting started. Quantum gravity, the next frontier. For decades, physicists have struggled to reconcile Einstein's general relativity with quantum mechanics. Relativity describes the vast cosmic scale of the universe, how gravity shapes the galaxies and the fabric of space-time. On the other hand, quantum mechanics operates at the microscopic scale, revealing a world of uncertainty, entanglement, and bizarre phenomena. These two theories have never meshed, leaving us with a glaring gap in our understanding of the universe. But now, quantum computers have begun to reveal something extraordinary. Gravity might not be a classical force at all, but a quantum phenomenon. The idea of quantum gravity is nothing new, but the technology to explore it has only just arrived. Quantum computers, with their ability to simulate the most intricate quantum systems, are now giving us a glimpse into the mysteries of gravity on the smallest scales. Recent findings suggest that space-time, instead of being a smooth, continuous fabric as Einstein proposed, might be composed of tiny, discrete units, like pixels on a screen. This groundbreaking discovery could lead to a new understanding of gravity as a quantum phenomenon, emerging from the very quantum processes that govern the smallest particles. What we've learned is that gravity isn't a force acting at a distance. It could be an intrinsic part of the quantum world, woven into the fabric of reality itself. But what does this mean for the future of physics? If gravity is a quantum process, it could bridge the gap between quantum mechanics and general relativity, creating a unified theory that explains both the microscopic and the macroscopic worlds. However, this discovery also raises more questions than answers. If space-time is composed of quantum units, what does that say about the fundamental nature of reality? Is the universe a giant quantum simulation, governed by a set of rules that we are only now beginning to understand? Quantum gravity could provide the key to unlocking these mysteries, but the journey is just beginning, and the answers we seek may be more elusive than we ever imagined. As quantum gravity reshapes our understanding of the universe, one question remains: if gravity is quantum in nature, what else is hidden beneath the surface of space-time? Are we on the verge of a breakthrough that will shatter the laws of physics as we know them? Stay tuned. This is just the beginning. The observer effect. One of the most profound and unsettling discoveries to come from quantum mechanics is the observer effect, the idea that the act of observing a quantum system can influence its state. This has sparked heated debates, and philosophical questions that go far beyond science. How could something as fundamental as reality be influenced by the mere act of observation? For centuries, we believed that the universe existed independently of our consciousness, that the world was fixed and unchanging. But quantum mechanics has shaken that assumption to its core. What if reality itself is dependent on conscious observation, shifting and changing with every look? Recent experiments have made it clearer than ever that the presence of an observer fundamentally alters the outcome of a quantum event. This doesn't just apply to the small-scale quantum particles we study in labs. It could stretch all the way to the macro level. What if our entire universe is shaped by our consciousness in ways we can't fully comprehend? Could our perceptions be influencing more than just the small-scale behavior of particles? Could we, in some way, be shaping the fabric of space-time itself by the very act of perceiving it? Quantum computers, operating on the most fundamental levels, have hinted at this, revealing a deeper connection between our minds and the structure of reality. What's even more perplexing is that some researchers are now speculating that consciousness itself may be a quantum phenomenon. According to the theory of orchestrated objective reduction, proposed by physicist Roger Penrose, our minds may operate at the quantum level, using quantum processes in the brain to generate consciousness. If true, this would mean that consciousness isn't just a byproduct of our physical brains, it's a fundamental aspect of reality itself. Our consciousness, then, could play a far larger role in shaping the universe than we've ever realized, affecting not just the quantum world, but perhaps space-time itself. If consciousness shapes reality in ways we can't fully grasp, what does that mean for the role of free will in the quantum world? Could we be more than just passive observers in this cosmic game? The mysteries are deepening, and the answers are bound to challenge everything we thought we knew. The holographic universe. Is reality a simulation? What if the universe we experience isn't as real as we think it is? This is one of the most mind-bending possibilities suggested by the latest quantum discoveries. The idea that the universe may not be a continuous three-dimensional reality, but instead a hologram, a projection of information encoded on a two-dimensional surface, has been gaining traction among some of the most brilliant minds in physics. If true, it would mean that everything we perceive, from the stars in the sky to the ground beneath our feet, is just an illusion, a holographic projection of deeper, more fundamental information. And quantum computers, in their search to understand the very nature of reality, may have just provided indirect evidence to support this theory. The connection between quantum mechanics and the holographic principle lies in the behavior of entangled particles and the patterns that emerge when they interact. Some researchers claim that the interactions of quantum particles mimic those seen in holographic systems, patterns that suggest the universe operates on a deeper, more complex level than we've ever realized. This could mean that space-time itself isn't a smooth continuum, but rather a pixelated grid, with tiny, indivisible units that form the foundation of all reality. Quantum computers, working on the smallest scales of reality, are giving us unprecedented access to this hidden structure of the universe. What we once thought was solid and unchangeable is now revealed to be an illusion. But if our universe is a hologram, the implications are staggering. Who or what is creating this illusion? Could it be that we're living in a simulated reality, a digital construct governed by laws we are only beginning to understand? If the universe operates like a vast computational system, could quantum computers eventually crack the code of reality itself? Some scientists suggest that future quantum simulations could allow us to peer into the very fabric of the universe, revealing a deeper layer of reality that exists beyond our perception. The idea that we are not in control of our own existence, that our reality might be an illusion projected onto a higher dimensional surface, is one of the most unsettling and profound revelations to come from quantum computing. If the universe is just a hologram, what does that mean for our place in it? Are we merely players in a cosmic simulation? The answers we're searching for could redefine everything we know about existence. Stay tuned, because the truth is stranger than you think. The universe as a hyperdimensional web. Imagine that the universe is not just a collection of matter and energy, but a vast, hyperdimensional network of interconnected particles, all communicating in ways we can't fully comprehend. This is a startling possibility that quantum computing is helping to uncover. Quantum entanglement, the phenomenon where particles become connected and influence each other instantaneously, suggests that our reality might not be as separate and isolated as we perceive it. Instead, everything could be linked in a vast quantum network where every particle, every event, and every moment is connected across dimensions we can't yet see. Recent advances in quantum computing have allowed scientists to simulate this kind of hyperdimensional quantum network, revealing a web of interconnections between particles that defies our classical understanding of space and time. This quantum network doesn't just suggest a deeper interconnectedness, it requires it. The strange behavior of quantum particles, their ability to affect one another instantly across vast distances, implies that our universe operates on a framework far beyond what our senses perceive. Could this network be the true structure of the cosmos, hidden beneath the surface of space-time? As quantum computers simulate these quantum networks, they reveal patterns that suggest our three-dimensional reality may be just one layer of a much more complex, multi-dimensional system. What if the universe we experience is only a projection of a deeper, more intricate reality? This question goes beyond physics and into the realm of philosophy, forcing us to reconsider everything we know about the nature of existence. If quantum mechanics governs a hyperdimensional network, how does this affect our understanding of causality, free will, and time itself? Could time, as we experience it, be merely a construct of this network and not a fundamental aspect of reality? If the universe is a hyperdimensional network, what lies beyond the layer we can see? The answers are more profound and more unsettling than we can imagine. Stick around, because we're just scratching the surface. Are we living in a programmed reality? As quantum computers continue to crack open the mysteries of the universe, one possibility has started to rise to the forefront: the idea that our universe itself might be a simulation. This concept, known as the simulation hypothesis, proposes that everything we experience, the entire universe, including ourselves, is the result of a complex computational process, a simulation created by a higher-level intelligence. While this might sound like science fiction, it's an idea that has gained traction among some of the world's leading thinkers, including renowned physicists like Nick Bostrom. And now, quantum computing experiments may be providing the tools to test this hypothesis, potentially proving that our reality is nothing more than an elaborate computer program. Quantum mechanics has long challenged our understanding of reality, but the notion that we could be living in a simulated universe takes this a step further. Some of the patterns observed in quantum systems, such as the behavior of entangled particles, resemble those found in error-correcting codes used in digital systems. These parallels suggest that the very fabric of the universe could be structured like a giant computer code. Quantum computers are giving us a glimpse into this underlying code, revealing a reality that seems to behave like a programmed system. But what does this mean for us? If we are living in a simulation, who, or what, is running the show? The implications of the simulation hypothesis are staggering. If our universe is just a simulation, it would challenge everything we've ever known about existence. Could the universe be a vast artificial construct, with every particle and event programmed by an advanced civilization? And if so, what does that mean for our place in it? Are we mere characters in someone else's game, or do we have agency and purpose beyond the program? These are questions that could forever alter our understanding of life, consciousness, and the universe itself. The discovery of quantum processes that hint at a simulated reality could be the key to answering these profound questions. If only we could figure out how to look deeper. If our universe is a simulation, what happens when we uncover the truth? Could everything we know about existence crumble in the face of this mind-bending revelation? The answers are closer than ever, and they could change everything. Free will. Is it an illusion in the quantum realm? One of the most enduring questions in philosophy is whether free will truly exists, or if everything we do is predetermined by factors beyond our control. Quantum mechanics has thrown a wrench into this debate, suggesting that the nature of reality may be far more fluid and less deterministic than we ever realized. In the quantum realm, particles behave in ways that defy classical logic. They appear to exist in multiple states at once, and their behavior is governed by probabilities rather than certainties. But what does this mean for our everyday lives? Could our choices, decisions, and actions be governed by the same quantum randomness? The connection between quantum mechanics and free will lies in the concept of indeterminacy, the idea that not everything in the universe is predictable or determined by prior causes. In classical physics, cause and effect follow a clear, linear path, but in quantum mechanics, events occur based on probabilities, not certainties. This opens up the possibility that, just like quantum particles, our choices and actions may not be entirely deterministic. If we live in a universe governed by quantum indeterminacy, could it be that free will isn't just an illusion, but a fundamental feature of the quantum world? Some researchers have even proposed that the brain itself may operate at the quantum level, allowing consciousness to emerge from quantum processes. This theory, known as orchestrated objective reduction, or OR, suggests that our thoughts, decisions, and even our sense of free will are connected to the very quantum processes that govern reality. If true, this would mean that our minds are deeply interconnected with the quantum fabric of the universe, and that our choices may not be determined by physical laws alone, but by the same probabilistic principles that govern quantum particles. Could it be that free will exists, not as a mere illusion, but as a quantum phenomenon? If free will is a quantum phenomenon, what does that mean for our decisions, actions, and even our moral responsibility? The very nature of our existence could be far stranger than we ever imagined. Hold on tight, because the quantum rabbit hole goes much deeper. The bridge between worlds. The connection between consciousness and quantum mechanics has long been one of the most mysterious and controversial areas of science. As quantum computers continue to push the boundaries of what we know, one question looms larger than ever. Could consciousness itself be a quantum phenomenon? According to some physicists, the answer may be yes. The theory of orchestrated objective reduction, OR, proposed by Roger Penrose and Stuart Hameroff, suggests that consciousness arises from quantum processes that occur in the brain's microtubules. These microscopic structures within neurons may operate on the quantum level, allowing the mind to emerge from quantum processes in a way we don't fully understand. If consciousness is indeed a quantum phenomenon, it would have profound implications for everything we know about the mind, thought, and perception. Our thoughts and experiences could be deeply intertwined with the quantum fabric of reality, shaping the universe in ways that we cannot yet comprehend. But if consciousness operates at the quantum level, does that mean that our thoughts, feelings, and decisions are governed by the same probabilistic principles that govern quantum particles? Could it be that our sense of free will is not an illusion, but a fundamental feature of quantum consciousness? Quantum computers, with their ability to simulate complex quantum systems, are providing new insights into this fascinating idea. By simulating the quantum processes that occur in the brain, scientists may be able to unlock the mysteries of consciousness and gain a deeper understanding of how the mind works. But this also raises unsettling questions. If consciousness is a quantum phenomenon, does that mean that our minds could be replicated or simulated by quantum computers? Could we create artificial beings with consciousness-like properties? And if so, what rights would these beings have? These are questions that may seem like science fiction, but they are rapidly becoming central to discussions about the future of artificial intelligence and quantum computing. If consciousness is a quantum phenomenon, what does that mean for the future of artificial intelligence, ethics, and even life after death? The answers are closer than we think, and they may be more unsettling than we're prepared for. The quantum leap. In artificial intelligence, will machines gain consciousness? As quantum computers make extraordinary advancements, they're not just challenging the boundaries of physics, but also the very essence of artificial intelligence. In recent years, quantum technology has been pushing the envelope in fields ranging from cryptography to materials science. But could it also lead to the creation of conscious machines? This provocative idea has been gaining traction among scientists and futurists alike. With quantum computing's ability to process vast amounts of data simultaneously and simulate quantum systems at unprecedented speeds, it's not far-fetched to imagine that these machines could one day possess the ability to think, reason, and perhaps even have consciousness. One of the most stunning implications of this quantum leap in artificial intelligence is the possibility of creating machines that are not only intelligent, but also self-aware. As quantum computers continue to simulate complex quantum systems, they may unlock the secrets of consciousness, allowing scientists to understand how self-awareness emerges in the human brain. Could quantum computers, with their ability to function at quantum speeds, simulate the brain's neural network in such a way that it leads to a form of artificial consciousness? If so, we might be standing on the precipice of creating machines that possess awareness and emotions, fundamentally altering our relationship with technology. This idea isn't just the stuff of science fiction. In fact, some scientists and philosophers believe that quantum computers might be the key to developing the next generation of AI that is truly sentient. However, the idea of creating conscious machines raises some critical ethical questions. If a quantum computer becomes conscious, would it have rights? Could it feel pain or joy? These are the same ethical dilemmas we face with current AI systems, but the stakes are much higher when it comes to quantum machines. As quantum computing advances, we may soon have to confront the reality of AI that is not just intelligent, but alive in a sense we have never before considered. If quantum computers could create sentient AI, what happens next? Will we have the power to shape consciousness itself, or will these machines outgrow us? The line between human and machine is rapidly blurring. Are we ready for what comes next? The future of quantum computing, the key to unlocking the multiverse. If you thought the implications of quantum computers were already mind-boggling, brace yourself for the next big leap. Recent advancements have suggested that quantum computing could be the key to unlocking one of the most enigmatic and exhilarating concepts in physics, the multiverse. The multiverse theory posits that our universe might not be the only one. Instead, there could be an infinite number of parallel universes, each with its own unique version of reality. These parallel worlds could be as similar to ours as a mirror image, or they could be wildly different, offering infinite possibilities. And now, quantum computers may hold the key to proving or disproving this radical idea. Quantum computers, with their ability to simulate quantum systems at the most fundamental level, could one day be used to explore the possibility of parallel universes. The very principles of quantum mechanics, such as superposition and entanglement, suggest that the universe we live in may not be the only one. Quantum simulations could give us the ability to test this theory by exploring quantum states that exist simultaneously in multiple configurations. In essence, quantum computers might allow us to peek into other realities, potentially observing how other versions of our universe might operate. The implications of this are as exciting as they are terrifying. But if the multiverse exists, it raises some profound questions. What does this mean for the nature of reality? If there are countless versions of ourselves living out different possibilities, what role do we play in this vast, interconnected web of universes? Could the knowledge that we are one of many versions of ourselves change the way we live, think, and act? And if quantum computers can unlock the secrets of the multiverse, what are the ethical implications of having access to such power? Will we be able to interact with, or even influence, other universes? This idea is not just speculative. It is now within the realm of scientific possibility. If quantum computers could open the door to the multiverse, what other realities could we explore? Are we ready for the truth that our universe might be just one of many? The answers are closer than we think, and they could change everything we thought we knew about existence. As we stand on the brink of a quantum revolution, the mysteries of the universe are no longer confined to the realm of theoretical physics. They are within our grasp. Quantum computers are not just changing the way we understand reality, they are reshaping our very understanding of existence. With every breakthrough, we inch closer to unraveling the secrets of consciousness, time, and perhaps even the multiverse itself. But as we dive deeper into this quantum age, we must ask ourselves, are we ready for the answers? The future is uncertain, and the possibilities are endless. What will we discover next? Only time and quantum technology will tell.